In this video we will talk about type 2 error. So what exactly is it? It happens when we miss something that's actually there, a false negative. Imagine going to the doctor with a disease that is treatable but the test comes back negative. You walk away thinking you're fine when in reality the illness is present. That's a type 2 error in action. The truth is real, but it slips past detection. Let's bring it into a different context. Picture a smoke alarm. If it blares loudly when you're just making toast, that's a type 1 error, an overreaction. But if your kitchen actually catches fire and the alarm stays silent, that's a type 2 error. The danger is real, but the system failed to respond. And here's where it gets interesting. Suppose we make our test more conservative by lowering the alpha level. That reduces the chance of a type 1 error, so we're less likely to make a false alarm. But there's a trade-off. By making that threshold stricter, we actually increase the risk of a type 2 error. In other words, we become more likely to hold on to the null hypothesis even when it's false. That's one of the central tensions in null hypothesis significance testing. Protecting ourselves against false positives makes us more vulnerable to false negatives. Fortunately, there's a way to balance this. By increasing the sample size, we boost the sensitivity of our test. With more data, we can lower the chance of both errors, keeping alpha strict while still maintaining the power to detect real effects. In statistics, we call the probability of making a type 2 error beta.